Hello everyone, welcome back to my YouTube channel. This is Sir DL and welcome to the Aliens Vlog and Math Tutorial. For today, we are going to discuss subtraction of radicals. We are going to discuss subtraction of radicals. What are the objectives of this lesson? Number one, discuss subtraction of radicals. Number two, solve and simplify subtraction of radicals. Number one, discuss subtraction of radicals. And number two, solve and simplify subtraction of radicals. Always remember, if you think you can, you can. If you think you cannot, you are right. If you think you can, you can. If you think you cannot, you are right. How do we subtract radicals? To subtract radicals, the indices and what is inside the radical called the radicand must be exactly the same. If the indices and radicands are the same, then subtract the terms in front of each like radical. Number two, if the indices or radicands are not the same, then you cannot subtract the radicals. As you notice, addition and subtraction of radicals are the same in terms of the rules, and I know you are very excited to apply it. Let's have an example. Let's try to apply these rules on our given example. What is 25 and square root of 3 minus 17 and square root of 3? To subtract radicals, the indices and what is inside the radical called the radicand must be exactly the same. Let's check. We have square root, both indices are the same. We have the same radicand, which is 3. We have the same square root of 3, square root of 3. That means we can subtract this one, then subtract the terms in front of each like radical. We will be subtracting the terms beside it, or the numbers beside it. That's 25 minus 17. That is 8, the square root of 3. We will just be copying the radical. That is 8, the square root of 3. As simple as that. If we have the same indices and same radicand, that means we can subtract the two terms. Then subtract 25 minus 17, that is 8. Then copy the radical, that is 3. Another example, 40 and square root of 7 minus 30 square root of 7. We have the same indices and we have the same radicand, so we can subtract these terms. 40 minus 30, that is 10, the square root of 7. We just copy the radical. If you have the same indices and radicands, that means you can subtract both terms. The 40, the square root of 7 minus 30, the square root of 7. That means 40 minus 30, that's 10. Then copy the radical, square root of 7. Let's have another example. 2, the square root of 7 minus 3, the square root of 5. As you can see, both indices are the same, but we do not have the same radicand because 7 and 5 are not the same. That's why if the indices or radicands are not the same, then you cannot subtract the radicals. But take note of this. There will be times that you need to simplify the radicals in order for you to have the same radicand. Can we simplify the square root of 7 and square root of 5? Okay, no, we cannot because 7 and 5 have factors which are the number itself and 1. There are only two factors for 7. Those are 7 and 1. Even for 5, those are 5 and 1. That's why the final answer on this problem is 2 the square root of 7 minus 3 the square root of 5. Because we do not have the same radicands, that's why we cannot subtract the radicals. So it will be like this, 2 the square root of 7 minus 3 the square root of 5. Another example, 10 the square root of 5 minus 3 the square root of 45. We both have the same indices, but the radicands are not the same. But can we simplify? The square root of 5 cannot be simplified because it's already simplified. Square root of 45 can be simplified. We just need to look for a factor that is one of the factors must be a perfect square, so we can simplify it. So we will be saying 10 the square root of 5. What are the factors of 45? And one must be perfect square. There are different factors for 45, such as 15 multiplied by 3. But 15 and 3 are not perfect square. That's why we cannot simplify it. Other factors are 9 multiplied by 5, it's 45. And the square root of 9 can be simplified. 9 is a perfect square. Always remember, if you want to simplify the radicals, you just need to have a factor which is a perfect square. Or you just need to have a factor which is a perfect square. As you can see, 9 is a perfect square and we can simplify this one. So we will be copying this. Then what is the square root of 9? That is 3. Then square root of 5. The square root of 9 is 3, then square root of 5. Next one, 10 square root of 5 minus 3 multiplied by 3, that is 9, the square root of 5. Okay, can we now subtract these two terms? Yes, we can, because we have the same in terms of indices and same in terms of radicand. That's why we can subtract this one. 10 the square root of 5 minus 9 the square root of 5. 10 minus 9, that is 1 square root of 5. Or we can write this one, automatically there's 1 beside the square root of 5. The final answer is the square root of 5. Another example, 3 and square root of 54 minus 2 and square root of 24. Do we have the same in this index? Yes, we have. Do we have the same radicand? We do not have. But can we simplify both radicals? Yes, we can. We will be simplifying the square root of 54 and the square root of 24 by simply looking for a factor which is a perfect square. What are the factors of 54? We have the square root of 9 and the square root of 6. 9 times 6, that is 54. 9 is a perfect square. We can simplify this one. For 24, we have 4 times 6. It's 24. And 4 is a perfect square. We can simplify the square root of 4. So what is the square root of 9? That is 3. Copy 3. Then the square root of 9 is 3. Square root of 6 minus 2. The square root of 4 is 2. Then copy the square root of 6. I hope you were able to follow. Again, the square root of 9 is 3. Then we copy 3. We copy the square root of 6. The square root of 4 is 2. Then we copy 2. Then the square root of 6. 3 times 3, that is 9, the square root of 6. 2 times 2, that is 4, the square root of 6. We can now simplify this one because we have the same indices and same radicands. Square root of 6. So 9 minus 4, that is 5. Then copy the square root of 6. This is our final answer. Another example. 12 the square root of 40 minus 2 the square root of 90. We have the same indices, but we don't have the same radicands. But I think we can factor out 40 and 90. And always remember, one of the factors must be a perfect square. What are the factors of 40? We have 4 times 10. And 4 is a perfect square. So we can simplify the square root of 4. For 90, we have 9 times 10. That's 90. And 9 is a perfect square. And we can find the square root of 9. Next one. 12 multiplied by the square root of 4, which is 2. Then square root of 10. Minus 2. The square root of 9 is 3. Then square root of 10. I hope you were able to follow. Again, the square root of 4 is 2. And the square root of 9 is 3. Then we can simplify this. 12 times 2, that is 24, the square root of 10, minus 6, the square root of 10. Can we subtract these two terms? Yes, we can, because we have the same indices and same radicands now. That's why we can subtract 24 minus 6. The answer is 18, the square root of 10. This is our final answer, because we cannot simplify the square root of 10 anymore. So the final answer is 18, the square root of 10. Okay, we're finished with our simple tutorial. I hope you were able to follow it. I hope you were able to follow the rules in terms of subtraction of radicals. Always remember, mathematics will always remind us that in every problem, there is a solution. Thank you for watching, everyone, and may God bless you. See you on our next tutorial.